My dear students, how are you? Namaste to all. Today I am going to deliver about the what is a very interesting chapter, that is what is valency, and that valency is very useful for knowledge as well as examination. Yes. So what is valency? That is also known as bonding. That is also known as linkage. So when talk about the valency, sometimes valency, that is bonding or linkage, these all are the same things. So when you talk about the valency or bonding or linkage, what do you see? So it is combining capacity of an element to form a compound. So when you talk about the valency, what do you see over here? It is the combining capacity of an element, maybe atom, maybe radical, maybe ion, to form compound. Yes, it is generally determined by number of hydrogen atom or chlorine atom or atoms present in a molecule of compound, better to say. Yes. So it is generally determined by number of hydrogen, maybe single atom, maybe more than one atoms, or chlorine, maybe one atom, more than one atoms present in a molecule of compound. Yes. So we take very simple example like this. Simple example. So on the basis of better to a, on the basis of hydrogen atom, or you can say atoms. Yes. So example is like this. HCl. So how many hydrogen over here? 1. So the valency of chlorine atom is 1. Why? Because in this case 1 hydrogen. Because in this case, in this molecule, 1 hydrogen atom. Yes. Likewise, when you talk about on the basis of suppose HCl, like when you talk about the water, that is the water. How many hydrogen over it? 2. So the valency of oxygen atom is 2. Likewise, when you talk about the ammonia, that is ammonia. So how many hydrogen? 3 hydrogen. So valency of nitrogen is 3. Like this, when you talk about that is methane, or we can say Mars gas. In this case, how many hydrogen? 4. So the valency of carbon atom is 4. So we have clear. So on the basis of hydrogen, how many hydrogen over here? 1. So valency of chlorine is 1. In this case, 2 hydrogen atoms. So valency of oxygen is 2. In this case, how many hydrogen? 3 hydrogen. So the valency of nitrogen is 3. In this case, how many hydrogen? 4 hydrogen. So the valency of carbon atom is 4. So that is on the basis of what we see hydrogen atom. Next one is on the basis of chlorine atom. Chlorine atom, maybe single atom, maybe more than one atoms. So example are like this. Example are like this. Suppose when you talk about HCl, how many chlorine? 1. So the valency of what is the hydrogen atom is 1. Like this, when you talk about that is the calcium chloride, how many chlorine over here? 2. So the valency of calcium atom is 2. Like this, when you talk about aluminum trichloride, how many chloride? 3. Trichloride. So the valency of what is aluminum atom is 3. Like this, when you talk about carbon tetrachloride, so in this case, valency of carbon is what is how much? 4. So you have clear. So in this case, how many chlorine atom? 1 chlorine atom. So the valency of hydrogen is 1. In this case, 2 chlorine atoms. The valency of calcium is 2. In this case, 3 chlorine atoms. The valency of aluminum is 3. In this case, 4 chlorine atoms. So the valency of carbon is 4. So I think so. Generally, valency of the any compound is generally determined by the number of hydrogen or number of chlorine atom present in a molecule. Yes. So that is about how to determine. Now what to say variable valency. If element has 2 or more valency, then it is known as variable valency. Yes. So for example, look at over here. So what you see when you talk about the ferrous, what you see, why it has 2 positive charge? Because it has 2 electrons. So that is ferrous ion. F3, it loses 3 electrons. What we have? Ferric ion. Likewise, when you talk about the what you see Cu2 plus Q plus, that is known as Q plus. So valency of copper is 1. Copper of valency of copper is 1 valency. In this case, what do you see? 1 valency. In this case, that is cupric ion. So in this case, copper has 2 valency. In this case, iron has 2 valency. Iron in this case 2 valency. In this case 3 valency. Yes, 2 positive charge. In this case 3 positive charge, so 3 valency. They are the valency. Likewise, 2 copper atoms. So that is known as cuprous ion. Yes, so for 1 copper atom, how many valency over here? 1. In this case, how many? 2 positive charge. So the valency of copper in this case is 2. Like this, stannous, Sn, that is known as stannous. In this case, valency is 2. Likewise, stannic, that is stannic. In this case, valency is 4. Likewise, other example, so variable valency. What do you see? More than 1 valency over here. So like this, when you talk about the plumbous, Pb, plumbous. So in this case, plus 2. How many valency? 2. That is plumbic. So how many valency? 4 valency. 4 valency. In this case also 4 valency. Yes, plus positive charge. Yes, that all are the positive, 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 positive. Yes. Likewise, when you talk about what you say, orus, Au, 1 valency, that is auric. How much valency? Plus 3 valency. Yes. And another so these all are the example of what you see, variable valency. Why? Because one element has one or one more than 1 valence electron over here. Yes. So you have clear what are the variable valency, what you say valency of the compound is determined with the help of hydrogen atoms and as well as chlorine atom. Next one, type of valency. So next one is type of valency. So in this case, we are talking about 3 types. So what one is electrostatic, that is also known as ionic. Next one is electrostatic, better to say electrovalent, electrovalent or ionic bond, that is covalent bond. And third one is coordinate or sometimes known as coordinate, covalent bond. Yes. So before starting this type of what is valency, at first we have to know octet rule. What we have to know? Octet rule. So always we have to keep octet rule and valence electron. So to form a stable compound, there must be 8 electrons in outermost orbit. Exception, I will talk later on. Exception is what we say inert gas, Lewis acid, aluminum chloride, boron chloride, iron chloride, phosphorus pentachloride, that is sulfur hexachloride, etc. you can say. etc. means etc. So these compounds do not follow what you see octet rule. So octet rule always to form a stable compound, there must be what you see 8 electrons in outermost orbit. I will talk when we talk about the what you see Lewis dot formula like this. So that is about the octet rule. Octet rules. I will give you so many examples of the octet rule later on. Next one is valence electron. Valence electrons. Those electrons which are responsible for bond formation and found in outermost orbit of an atom are known as what you see atom are known as valence electron. Valence electrons. For example, I have already taught you about the electronic configuration. So what you see when you talk about the sodium. So in this case, proton number is 11, electron number is 11. So when you talk about the electronic configuration, 2, 8, 1. So outermost orbit is how many electron? 1. So its valence electron is 1. Likewise, when you talk about magnesium, what you see? Proton is equal to 12, electron is equal to 12. So what you see? 2, 8, 2. In outermost orbit, how much? 2 electrons. So its valence electron is 2. So you have clear? So those electrons which are found in outermost orbit and which are responsible for any bond formation, so they are known as valence electron. Yes, you have clear? What are the octet rule? What are the valence electron? Yes. Now talk about what you say electrovalent. First one is electrovalent bond. First one, electrovalent valent, or we can say ionic bond. So such type of bond, such type of bond is formed by complete transfer of electron from metal to non-metal. Yes, these bonds are these bonds are, we have to keep in mind, these bonds are present in halides. Halides means maybe X negative charge, maybe chloride, maybe bromide, maybe iodide. Yes, oxide, O2 negative charge, oxide, and sulfide of the metals. So generally electrovalent compounds are found in any halides, any oxide, any sulfide of the metals. Yes, so always keep in mind metals, not in non-metals. Yes, so look at the example over here. So for example, sodium chloride. Now how it is, what do you say, ionic compound, electrovalent compound. Yes, so you know, when you talk about the Na, its atomic number is 11, it means proton number is 11, electron number is 11. Yes, when you draw the diagram of this one, so you know that is the, what you see, proton and neutron. Yes, that is the nucleus, that is the first orbit, that is the second orbit, that is the third orbit. So always keep in mind, in first orbit there are 2 electrons. In second orbit, what you see, 1, 2, 3, 4, 5, 6, 7, 8 electron. Yes, in last orbit is what you see, 1 valence electron. So in this case, valence electron is how much? 1, because outermost orbit is only 1 electron. Yes, so when you talk about this sodium metal, so how many proton? What's the atomic number? 11. Proton number is 11, electron number is 11. Likewise, when you talk about the, what you see, chlorine, what you see, 17. It means proton is 17, electron is 17. So when you draw the atomic structure of this chlorine atom, so what you say, P17 neutron. So what you say, so that is the nucleus, you can say that is nucleus. So you know nucleus has general positive charge. So what you say, in first orbit, that is the second orbit, that is the third orbit. So we have already studied K cell. First cell is K. It has 2 electrons. Yes. Second one is 2, 1, 2, 3, 4, 5, 6, 7, 8 electron. So second orbit, what see, 1, 2, 3, 4, 5, 6, 7, 8. Third electron is how much? remaining one is 7. So what do you see? 1, 2, 3, 4, 5, 6, 7. Yes. So that is known as K cell. You know, K cell. That is known as L cell. That is known as M cell. Yes. So what we observe over here? So in this case, one electron in outermost orbit. In this case, how many? In this case, valence electron is 7. So always keep in mind, metal has tendency towards lose electron and non-metal has tendency to gain electron. So in this case, it needs one electron for stability. Yes. So sodium transfer one electron to what do you see? Chlorine atom. Why transfer to chlorine atom? Because it has in outermost orbit has only one 7 electron, and for filling, for getting, what do you see? According to octet rule, there must be 8 electron in outermost orbit. Yes. So what we observe over here? So in this case, proton is 11, electron is a never. But when it loses one electron, so what do you see? When electron loses one electron, then it has only 10 electron. The number of proton is 11. So in this case, what we see? Sodium positive charge. Now we are clear why sodium develops positive charge. Why? Because it loses one electron. Transfer one electron to what we see? Non-metal. So it has one positive charge. Yes. Likewise, when we talk about the chlorine, so what we see? It has 17 electron, but when it gains one electron, so how many electrons over here? 18 electrons. Proton is 17, electron is 18. So how much? So chlorine has negative charge. So before the formation of compound, there is formation of cation, that is known as it, what do you see? It loses one electron. So how many electron over here? 10. So when 10, it means it has positive charge, that is known as cation. That is known as anion. So before the formation of what we see compound, what see? There is formation of cation and anion. Yes. And now this formation of this cation and anion, so what we get? Sodium positive charge, chlorine negative charge. So when there is mutual exchange, and what we get? Sodium chloride. So sodium chloride is what you see? Ionic compound. Why it is ionic compound? Because before the formation of compound, there is formation of cation and anion. And after the formation of cation and anion, what you get? Compound like this, plus come here minus one balance over here. So what you get? NaCl. That is ionic compound. So one example. Next one is second example is magnesium oxide. Magnesium oxide. Yes. Magnesium. So talk about the magnesium. Symbol of magnesium Mg. Atomic number is 12. Proton number is 12. Electron number is 12. So when we draw the diagram, so what do you see? Proton, neutron. Yes. How many proton? 12. Yes. In this case, neutron is how much? 12. Yeah. So that is the first cell. This is the second cell. That is the third cell. Yes. So in first cell, so always keep in mind, K cell has only 2 electrons. L cell has 2, 3, 4, 5, 6, 7, 8. 8 electrons. And third one has how many? Remaining one is 2 and 8, what do you see? 10 electron. So, in outermost orbit, 2 electron. So, in this case, valence electron is 2. Likewise, when you talk about what you say, oxide, what do you see? Oxygen has 8 atomic number, proton is 8, electron is 8. So, when you draw diagram, what do you see? Proton 8, electron 8, neutron. So, that is the nucleus, first cell, second cell, yes. So, in this case, we need only 2 cell over here. So, what do you see? In first K cell, 2 electron, second 1, 2, 3, 4, 5, 6. So, in this case, valence electron is how much? 6. Look at over here. In this case, valence electron is 2. In this case, valence electron is 6. So, what do you see? According to octet rule, there must be 8 electrons in outermost orbit. So, in this case, only 6 electrons. And also we know non-metal has tendency to gain electron and metal has tendency to lose electrons. So, always keep in mind. So, what we see? 2 electron from magnesium shift to what do you say? 2 electron come from what do you see? Magnesium to oxygen. So, now what do you see over here? In this case, it gains 2 electrons. So, how many electrons over here? 10. Proton is 8, electron is 10. So, how much? Oxygen has 2 negative charge. That is the anion. In this case, what we see? It loses 2 electrons. So, how many electron over here? 10 electron. Proton is 12. Electron is 10. So, what do you see? In this case, magnesium has 2 positive charge. Yes, that is cation. That is anion. So, before the formation of compound, what do you see? Formation of cation as well as anion. So, what we have? Magnesium has 2 positive charge, oxygen has 2 negative charge. When there is mutual exchange, so what you get? Magnesium oxide. That is also ionic compound. Why? Before the formation of magnesium oxide, there is formation of cation as well as anion. Yes, and that is known as nucleus. That is also known as nucleus. Third example is like this. Sodium sulfide. What you see? Na2 yes. Yes. So, you know sodium has 11, proton is equal to 11, electron is equal to 11. Yes. So, when you draw the diagram, what you see over here? So, what you say? Sodium sulfide. So, when you talk the what's electronic configuration, you know. So, what is it? 281. Sulfur. What is it? 16. Proton is equal to 16. Electron is equal to 16. Yes. So, what you see? When you draw the what you see electronic configuration? 286. Yes. Next one is sodium, 2 atom over here. Sodium is 11. Proton is equal to 11, electron is equal to 11. When you draw what you see? electronic configuration, what you get? 281. In this case, valence electron is 1. In this case, valence electron is 2. In this case, valence electron is, let's see, 1. So, according to octet rule, sulfur needs how much electron over here? So, this is the 6 electrons. It needs 8 electron for fulfill the what's the octet rule. So, 1 electron from sodium goes to what to say sulfur. 1 electron from here goes to sulfur. Why? Because it needs 2 electron over here. And also you know कि metal has tendency to what you see lose electron, non-metal has tendency to gain electron. Yes. So what you see over here? When it loses 1 electron, how many electron over here? 10. It means it has 1 positive charge. Sulfur has what you see? It gains 2 electrons. So how much? 18 electrons. It means it has 2 negative charge. That is anion. That is what you see? It loses 1 electron. So how many electron? 10. So it has 1 positive charge. Yes. So that is cation. So before the formation of what you see this compound, what you see over here? So what you see? That is also cation. That is also anion. So what we have? Positive charge, negative charge, positive charge. What do you see? We get what type of compound over here? We get how many sodium atom? 2 atom. So what you get? 2 sodium atom and 1 sulfide. That is known as sodium sulfide. Yes, I think. So before the formation of what you see compound, there is formation of cation and anion. And after formation this, what we have? What you see? Formation of compound. Yes. So that so for today, this is the what you see. I thank you for watching this what you see video, and I will give you about the second, third type and Lewis dot structure in second part. Yes.